Hello, my name is Peter Parfitt. Welcome to the new Brit workshop. I thought it'd be useful to put measuring and marking all in one video. Now, some people have misconceptions. They think that woodwork, well, wood is very malleable and a hammer is quite heavy, so you don't need to be more accurate than 1/8 of an inch or a couple of millimeters. Well, I'm afraid that's not true. If you're doing cabinet work, and I don't mean making kitchen cabinets, I mean finer woodwork, then accuracy is very important. So I've put together some kit, and I'm very grateful to my good friend Peter Sefton at the Woodworkers Workshop, who's lent to me a number of items, and those will be shown to you as well. Now, I'm going to start with the basics, and most of this stuff is stuff that I've owned for a long time. I've got my 60 centimetre steel rule in my hand, and also an old Stanley tape measure. I've had these for a long time, and I know them to both be very accurate. But how do I know that? Well, it took me a few years actually to establish that. It may sound silly, but I used to assume that when I bought a tape or a steel rule or a square or whatever it might be, that it was going to be okay, and I never bothered checking. But over the last few years I've become a little bit more sceptical. And so if I'm buying a steel rule or a tape measure, I take a known good item with me to check it. And I'd go into the shop if I was about to buy a tape rule, and I'd take my steel rule with me, and I'd do a comparison. Well, that's fine, but how do I know my steel rule is accurate? Well, what I did was a system of voting, and to be honest, I don't really know that this is absolutely accurate, but it agrees with the majority of other measuring devices I've got. Have a look behind me. Now, I've got two tape rules here and the one in my hand, and these all agree with my steel rule, so and absolutely spot on as well. But these two tape rules are about a millimetre out over 60 centimetres. So I've established that these three tape rules and my steel rule are good because all of those agree. These two do not agree with that, and these two do not agree with each other. So my process of elimination is to say that these two are wrong. And the same is true of squares. Now, these two were given to me by my father, and I cherish them, and I will never ever let them go. But I don't use them. And the reason I don't use them is they're just not accurate enough. And when I discovered that, it broke my heart really. But and the way to check is to take one that you think you might want to buy and get some others from the shelf and make a comparison. And try and find a set of at least three that all agree, and there's a good chance that those three are probably right. There are more technical tests. If you had a piece of wood and you could put the square on the piece of wood, draw a line from one side and then reverse the square and see if that line is still square, then that's a good way of doing it. But I don't use this type of woodworker's square at all. They're just not reliable. What I use is an engineer's square. This is my large one. And this came from the Woodworkers Workshop a long time ago. I have two smaller ones. This one from Incra, and that is their guaranteed square. This is a small one. And I have a small engineer's square as well. And all of these agree with each other, and they're absolutely spot on. And professional friends of mine who have been woodworking for years, they do exactly the same. They don't use the woodworking squares, they use engineer squares. It's by far the best way of going on. And it's particularly important if you're setting up machines. You've got to be setting up your machines with something that is really accurate. Now, when it comes to layout work, these are the tools that I prefer for that. And the star, as far as I'm concerned, is the Incra Precision T rule. I've got two of them. This one is the metric 150mm one, and I've got this one, which this is the first one I bought. This is the metric 300mm one. The reason I bought the shorter one is that the long one is quite floppy and it's perfectly accurate, but when I'm doing shorter work, this is much easier to handle. And all you do is you put your pencil through the appropriate hole and then If you want to draw a straight line, you can use it like so, and there's that line. Or just here, you may just be able to see there are some elongated slots, so you can put your pencil in there and just wiggle it to and fro, and you've got a short mark like that. And this is a particularly good tool if you're doing domino work, the Festool domino machine. This is what I try and use almost all the time for laying out my joints. Now, when I want to measure the thickness of something, I usually use my calipers. I can put those on, and the way the scale works is such that you can easily get it to within 1/10 of a millimetre. That's not bad. And a lot of machines can be set up to within 1/10 of a millimetre. And for the skeptics who say, well, woodwork, 0.1 of a millimetre, well, let me tell you, when you do a bit of planing, those shavings are coming off at a lot less than 0.1 of a millimetre. Now, this is the old-fashioned caliper, if you like. One can go to the digital world and get one like this. And I'm very grateful to the Woodworkers Workshop for lending this to me. This is the eye gauging Absolute, and it really is super duper. You don't need to zero this caliper. Turn it on and it's on in the zero position. I move it out to whatever, it's giving me an accuracy of 2 decimal places. And if I turn it off, move it to wherever it is, measure the thickness of this piece of wood, and then turn it on, that's the thickness of that piece of wood. So you don't have to start in the zero position. Now, I was lucky to get this one back. This has been in the hands of a local professional woodworking friend of mine. He is a master craftsman, cabinet maker, furniture maker, and he makes the most wonderful stuff. And he said to me ages ago that he gets through calipers and throws them away, but when he suddenly discovers they're not accurate. So he had this one for over a week. And he said this was the nicest, sweetest bit of kit he's ever had. And it was very difficult to get it back from him, I must tell you. But he's going to get some of his own. So that's the eye gauging caliper. And I rather like eye gauging stuff. This is a height gauge, which I bought from Lee Valley, at least 2 years ago, maybe more. And again, it's digital, and I'll show you that in operation now. Now, for height adjustment, for years I've used a cheap and cheerful little gadget like this, made of plastic with a little metal rule in there, and this was good to within about 0.5 millimetre if I was lucky, but it's fine. But my style of woodwork has changed now, and my standards are different. So a while ago I bought this eye gauging height measurer, and I bought it from Lee Valley in Canada, and what you do is you turn it on, and then push it down so it's flat on your bench surface or work surface, and press the 0 button. And then I'm now going to move this over so it's sitting above where the router bit is, and I can now raise the router bit, and at the same time I can see the scale moving here. Now, this has got a magnetic base to it, and so if this were a cast iron top, then it would stick like glue. But my top here is aluminium, so I'm just keeping a little bit of pressure here as I was doing that process. And what happens if you want to measure angles? Well, this is another eye gauging product, and again, I'm grateful to the Woodworkers Workshop for lending this to me. This is the Angle Cube, and it's a digital angle measuring device. Now, if you wanted to check how accurate your mitre saw or table saw, whatever it might be, was when you set it at an angle, well, this is the sort of gadget you could use. Now, everything's turned off, there's no power going to this machine. So you can just attach the gadget to your saw blade like so, and turn it on, and then it'll come up with a reading, and I'm going to now zero it. So that's now saying 0 degrees. Now, if I now change the angle, and I'm going to move this over to what I expect to be 30 degrees, which is there, and that is reading 30, and here on my scale at the back it says 30. And I'll now continue this on to 45 degrees, and there I am at 45 degrees, and that says 45.1. Well, frankly, that's good enough for me. I'll put this back to the 0 point. Lock that in place, and I don't know if you can see there, but that says 0 again. So I'm very happy with my miter saw. Well, it's a festival machine, isn't it? It's got to be good. And the same is true with the table saw. You do have to watch the kerf of the teeth. Sometimes they're sticking out a little bit. I'll just 0 that, and so I could use this to set a precise angle, and then once I'm in the position I want, I can then reach under and just lock it in place like so, and there's one at the front as well, like so. Now, supposing you could take the digital technology that we have in this caliper and separate the display from the Gubbins here, which does all the actual funny electronic stuff. You'd end up with something which looks a little bit like this. Here you have the mechanism which has the clever Gubbins that moves up and down, and here you have a display. And if I turn this on, in one position it will be reading close to 0, and the other position, if I move all the way up here, is going to be close to 30 centimetres or 300 millimetres. So we've now got something which allows us to put this in one place and this clever Gubbins somewhere discreet and out of the way. Now, one place you could use something like this is with a planing machine. Now, with my jet planer thicknesser, when I'm thicknessing, one alters the thickness of the cut by cranking this handle here. And ordinarily, with the machine as it's supplied, there is a sight gauge here, which gives you an approximate idea of where you are. I've added an optional mechanical digital gauge, which is here. And if you've seen my video about this machine, you'll know all about that. But now with this new gadget, one could put the Gubbins somewhere out of the way. And you can mount the clever Gubbins somewhere like here on the right of the machine, out of the way, and that could be screwed onto the frame. And on the back of the part that moves are a number of different places where you can make screw fixings. And there's a hole here on this particular machine which has been tapped, and so one could make a very simple little piece of metal which linked the bed here to this part here. And you can then imagine just how easy it would be as the bed moves up and down, so this would move too. Now, the other side of it, of course, is this part. And I'll turn it on now so you can see that. The clever thing about this is that on the back it's got some magnets, so you could stick it wherever you like. And there's also provided with the kit a little proper mounting kit for a permanent mount if you wish to have that as well. So this has got all the characteristics of the digital caliper that we saw earlier, but this time you've got this remote readout. And it would be perfect for not only planing machines, but perhaps spindle moulders, some types of table saw as well. And once again, I'm really grateful to Peter Sefton at Woodworkers Workshop for lending me the extra eye gauging digital measuring items. I think Eye Gauging is a great company, and I've been very pleased with the digital height gauge, which I bought several years ago. Thank you very much for watching. Take care. Bye-bye.